Alrighty, so this is our last lecture of the semester. This is your review lecture. So we're just gonna go over the two most missed problems. I haven't finished grading exam 3 yet, so I don't know that yet. Missed problems on the first two exams. Okay, so the first one is problem 10 from exam 1. And you're asked to solve this nonlinear inequality. And the things that I see gone wrong a lot on this one is that you guys factor and then you just are, here's the answer. Where factoring is like not that much of the problem. And the rest of it of showing and testing the values, that's majority of the problem. Okay. So since our final and all of our exams are open note, if you look at the notes, it kind of gives us a step-by-step of how to solve inequalities, right? So our first step is we want everything onto the same side, right? So, excuse me, I have 6x squared plus 19x minus 36 less than 0. Okay. And this was a little bit of a tricky factoring one. I'll give you that, but you've actually already done that because this was in like problem 2 on the exam. So I'm just going to scroll up to problem 2 because I forgot what that factoring is. Problem 2. Oopsie, it's not problem 2. Maybe it's problem 2. Oh, problem 4. It was this guy. So it's going to be 3z minus 4 2z plus 9. So you can pop down here a few. So we have x's, so it's going to be 3x minus 4 and 2x plus 9 is going to be less than 0, right? So we want to find x values that yield this inequality. And if we're given an inequality, our answer's in an inequality. They match up. I can't just have x equals that. That's also not even getting me the right answers if I solve for 0 because I want things that are less than 0. Okay, so our next step is to solve the equality. So I set it equal to 0 for the purpose of distinguishing my intervals. So we know from the 0 product property that these two things are equal to 0 if one of them is equal to 0. So we set each one equal to 0 on our own, and each one, I mean each factor. And we solve for x. So we get x is 4/3 and x is -9/2. Okay. And we can draw on a little number line and see that we have like -9/2 down here and 4/3 over here, like 0 over here. So this is our number line. And the point of setting it equal to 0 is this is where the inequality, this is where this guy would equal 0. Now I need to find where it is less than 0. If you remember back to solving our inequalities, a function can't go from being positive to being negative without hitting 0. So that's why it's important to do that. Okay. 1 second. Grab my water cup. Okay. I'm so thirsty. It's so hot outside. Okay. So it's too close to my computer. We have our number line now, and I know where this expression equals 0. So now what I'm going to do is I'm going to take a value from each one of these intervals, right? So I have this interval, which is like -∞ to -9/2, -9/2 to 4/3, and 4/3 to infinity. Those are all my intervals that I could possibly have in my answer. I can't include -9/2 or 4/3 because that's when the expression equals 0, and that's not what I'm looking for. I'm looking for when it's strictly less than 0. So I'm now going to test some values. So I'm going to pick like -5, 0, and like 2. Okay. X equals 5. And the best thing to do it is to plug it into the factored form. So like 3, 5 minus 4, 2, 5 plus 9, because that'll give you a quicker way of solving. So 15 minus 4 is 11, and 10 plus 9 is 19. So that is greater than 0, and I do not want that. So no. So then I'm gonna plug in x equals 0. That's always an easy one because then I'll just get -4 and 9, and that's gonna be less than 0. A negative times a positive is a negative. So great, that one's in. And then x equals 2, we'll have, what is that? 6 minus 4, hi Duke, and 4 plus 9, which is 2. And oh, I should put in plugging -5 in. I'll do that one again. 13, and that's going to be greater than 0. So that one's not it. I should have been plugging in -5. And I don't think that changes our answer though. So why didn't I get any negative answers? -15 minus 4 give me -19. And -10 plus 9 give me -1. So negative times a negative is positive, greater than 0. I don't want that. So great. So the interval that had x equals 0 is my winner. So then I'm going to go over here. Right. Wait, did it tell me how to write my answers? Using interval notation. Okay, cool. 9/2 to 4/3. And the reason that we're doing open brackets is because we're told to find when it is less than 0, but not less than or equal to 0. Okay, so a lot of you guys missed the points because you factored it and you're like, ta-da, and then there's the answer. You completely didn't do the number line, didn't test functions at all. So I have no idea how you got that answer. Basically, there's no work to support your answer. So I need to see that work, okay? And then the second part of this, you guys all did great, which was just to graph the solution. And I think you guys are pretty great at that. All right, so next problem that we're gonna look into is on exam 2. I just pulled it up. Yeah, and it's problem 7. This is always a tricky problem, but if I just always give you guys easy problems, then what are you learning? You guys did a lot better than most people have on this problem. I usually only get a few correct, and I got a lot of correct this time, but still it was the lowest one on the exam. All right. So if Lisa only drinks coffee that contains 25% creamer, right? So she prefers 25% creamer, 75% pure coffee. One morning, she is overzealous in her creamer and pours enough to make her standard mug of 16 ounces, 2 times the amount of creamer she prefers. So her first cup of coffee was like, if it's 25%, she has 50% in there, right? So she's like 50% coffee, 50% creamer. I guess creamer would be on top. Do the difference in density in liquids, Lisa can pour out the creamer. Basically, I can remove the creamer without worrying about removing coffee. That's kind of all that that's saying. It's not even true. I think coffee is less dense, but that's not the point. She can pour out creamer without reducing the amount of coffee in the mug. There's a little hint, without reducing the amount of coffee in the mug. She does this until she can drink it, right? So she's pouring out creamer. Creamer is leaving her cup. So we're asked to construct a model that gives a fraction of Lisa's drink that is pure coffee. I even underline it for you guys. And a lot of problems on this problem is you guys were giving me a model for creamer and then would solve it like it was the one for coffee. Or you would solve it because you knew it was creamer. It's a very interesting problem. So constructive model gives a fraction. There's a hint, fraction of Lisa's drink that is pure coffee. So let X represent the ounces of pure creamer being poured out. So this is one of our concentration problems. I'm told that it's a fraction. And when we're working through these like word problems, let's put everything into words and then slowly add in some values, right? So my concentration is going to be ounces of pure coffee, and that's not changing with X, right? I said without reducing the amount of coffee. So the amount of coffee, like pure coffee, is not changing. The amount of creamer is, right? And then it's going to be the ounces of drink minus X. So minus creamer pouring out. You could also do, I saw people doing plus X, will just get a negative value out. And so you kind of need to be careful about that. Okay. So then, how many ounces of pure coffee does she have? Well, if she has 50% coffee and 50% creamer, 50% of her 16 ounces is coffee. How many ounces in her drink? Well, she starts with 16, and then I'm going to pour out X. So we were told that's what X was. So 50% of 16 is 8, 16 minus X. Great. So that is our equation. All right. And then I just needed to see a little bit of, a lot of you guys also just gave me an answer without any work, which is not allowed. So how much creamer must you pour out? Remember, I want to find, this is a concentration of coffee, right? So if it's 25% creamer, I'm not going to set this equal to 0.25, 25%, because that is concentration of creamer. And this is concentration of pure coffee. So I'm comparing apples to oranges. So I need to think of, if she wants 25% creamer, that means she wants 75% coffee, right? So you're okay, bud. 16 minus X. And then we solve for here, right? So I put 16 minus X over here. 0.75 equals 8. And then I can do like 16 minus X, and this is going to equal like 10.66. Yeah. And then 16 minus 10 point equals X. And so we get that X equals 5.33. And then you could say 5.33 ounces, right? Because we have to give units here. We're given a lot of units prior. So we need to give units back out. Okay. And then I was trying to help you guys by asking you to plug into your solution, right? No matter if your equation was wrong and your solution was wrong, as long as you plugged it back in and got what you wanted to, 0.75, you got the points. So I was trying to like also guide you to see that, oh, maybe because I see the common answer for this is 4. Oh, she just takes out 4. Then she'll have 8 ounces. Like it'll work out. But when she plugs in 4, she would get 8 over 12, which is like 2/3, which is not enough. Okay. So you need to take out a little bit more to handle that. So if we go over here and we use C of 5.33, we get 8, 16 minus 5.33, which is 8 divided by 10.33, which is 0.75. Rounded to a little bit since we rounded the 10.33. All right. And that's how this problem is done. That was, I think, the most missed problem other than, what was problem 1? Oh, that's on exam 1. Yeah, this one was definitely the most missed by a lot. And then the problem before this was also missed a little bit more, but a little bit less. I had a higher percentage of points. But yeah, and that's how you spell my name. Okay, so that's all that we're going to talk about today. If you have any other questions, please email me. We can go over them. I am a grading slave today. So have a good day. I hope you guys have fun on your final. You're going to do great. Final push. Do your extra credit homework. Okay, bye.